Mm-hmm.
So just some shopkeeping to start. Where did the cover page go? Where is that stinking cover? Oh, it's over here. Great. Okay, so some shopkeeping to start. On this, really great. This is one of the first times I've seen you identify what was something in the class that might have translated to this misconception. So didn't stamp the difference between solution and the answer in context. That was great. One thing I wanted to flag for you is I saw reteach factoring on Flex Day.
Yeah, I have a reteach day Monday, and the big gap has been students are factoring really, really slow, and it's we've gone over this a few times, but if we're the ones that were at zeros were often not done, and they're showing me they've done factoring, but
we should talk about what that reteach looks like, because I fear reteach factoring on sounds like teaching it again instead of targeting a misconception. Okay. So we need to figure out what is the thing that's making them be slow.
That lesson is uploaded. Okay. I wonder.
I'll take a look.
If we could, yeah.
I'm looking at that this afternoon.
Okay.
So this is good. Really good to see that this stamping the difference. I get nervous when I see a reteach and it's a big old thing, because we know we want reteaches to be what is the misconception. I caught a couple more that you give half credit to. What's the danger in giving half credit?
Yeah, they think they're kind of right when, yeah. And I mean, I'm going to say something you're going to hate. They are right. 10 plus 8 is 18. And they'd get credit for that on the AP test.
You need to hold out for right is right.
Okay.
That is not right is right.
Right. I
That
felt
is
right,
right, but not right.
Yeah. Yeah.
It's not their best work.
Yeah. I think I need to change my mindset. I've been looking at my grade book and I'm I can't keep putting in 50s.
But rounding up for their answers is not the way to solve that issue.
Yeah. Yeah, you're right. You're right. I need to hold out.
Same thing for this. They put the answer all the way down here, which I've noticed maybe the kids just need more space. But down here, I shouldn't have gotten credit. Because this, you drew an arrow for them, but that's not, where it should go.
You would mark A wrong because they wrote it
in the wrong
lower?
spot. Yep. Because it looks like he thinks, the way I looked at it, looks like he thinks that negative 15 and 10 are the solution to the length and the width.
Okay. Yeah, that makes sense.
Even though it goes with up here. I think there's more space. But quick shopkeeping stuff. That's hold out for right is right. They can do it. They can do it.
Yeah.
Let's dive into this stuff, though. So last time we worked on using that specific model for guided discourse, and I made you the little quarter pager. And you showed 2 problems. You had them discuss which one met better at the CFS, and you stamped the big idea. So what was the positive impact that day? And how can you see that playing out in your class, that model, in the future?
Students are always pulling out that GCF every single time, so it's good that every single student knows how to start, and they don't make that mistake anymore. So identifying that misconception means they're targeting that and they're not making that mistake. So I think thinking in the future, if we can just find that mistake and leverage it, if the difference is we need to stamp the difference between x equals 10 and x equals negative 15, and okay, then what is the answer in context? If we can dive into that difference, which this paper does a good, the work's not shown, but it does a good idea of what is the difference, then we could have students never missing answers in context, which would be really great.
And that model, that's a different one, we'll get to in a minute, but that model, I distracted you, sorry. That model, that guided discourse we did before, I'm going to cover it, okay. The model, the guided discourse we did before is something that it will become a routine in your class. Achievement first, that's where I got that from. That's what they do every time for their reteach. It's the same setup. The kids could probably even draw it. So, I'm going to sneeze.
With the 3 boxes, where it's
Yep. They show the 2, they cross one off, they write the big idea.
Here's 2, cross this off, big idea.
Yep, that's what they do every single time.
Okay.
And so kids, it's part of their routine there. So today we're going to dive into this objective word problems. And so usually we zoom into a standard, but this is an application of a standard. So in particular, the objective was, and I'm making sure I capture this right, for these word problems for students to interpret the word problems to create and solve equations using one variable by using factoring and the zero product property.
Yep.
So real quick, in your own words, what do students need to know and be able to do to master this standard?
I think the criteria for success on this is somewhat good. I think the thing I would have added in here is draw a picture because like interpreting the word problem with a picture, which is something that every kid did, because like we stamped that as a key point.
They did do that.
Right, like we had that as a key point up in here, and like what should you do every time? It's somewhere in here, but it doesn't matter. Like draw that picture first. So I would say that it's a do skill. Like
Okay, make a list for me. Take 30
sorry.
seconds. No, it's okay. Take 30 seconds and list it out. Know and do. I wasn't clear. Because I have one too, and I think it's always helpful to spar, and I always end up adding to mine.
Cool. So
Let's start with the do.
great. They need to be able to multiply polynomials, solve quadratics by factoring, which has steps in it, and substitute in a solution to get an answer in context.
I also said two things. Write an expression with one variable given information.
Right.
And then one of the things I got right from your criteria for success was manipulate an equation to form a quadratic equivalent to 0.
Right. That would be a step in here that, yeah, exactly.
And then for the no statements, what did you say?
They must know that quadratics must equal 0 to solve. Got to move that 126 over. They need to know how to differentiate between their solution and their answer. And they need to know what extraneous means in context.
I don't like how I captured my wording, and so I'll just say them and we can maybe land on something. I put they need to know what solutions will and will not work in the context of a scenario problem. I think that goes along with your like answer solution thing, but like
Yeah.
they need to know that not all solutions will be reasonable.
Right.
But that goes along with the extraneous thing, so I think we captured it. And the second thing I said was, and again, I don't like the wording of this, but the solutions found from factoring are possible options for a solution. Like knowing that, like, and again, it goes to that extraneous thing, just like understanding conceptually that like some are right and some aren't. They're possibilities.
I feel like maybe it's captured as solutions make the math true, but not the situation true necessarily.
That's
right?
sticky. Write that down. That's sticky. The solutions make the math true. Whatever you just said.
All the solutions make the math true. But only some will make sense in context.
And that's something we're going to do a model a little bit later. That's very sticky.
That's like a big idea to me.
Okay, let's switch gears and talk about your exemplar. What are the keys to an ideal response? You can kind of talk me through.
Yeah, so the first thing is that they'd be able to write this equation. That's like the big idea and the first thing they've got to be able to do. And a lot of students got to that point by like drawing the picture. So I would even before that say draw the picture, then write the equation is like length times width. The next big step is, it doesn't matter what you do first, but multiplying this or subtracting 126, but to get to a trinomial that's equal to 0, that's the big idea, the manipulating part. once you're there, got to be able to factor, and every student that I saw that could factor it could solve it. So factor or solve.
I would agree. Okay.
Then part B, they need to be able to substitute the reasonable solution in, so which means they have to differentiate between which one is reasonable and which one is not. Only 10 is reasonable. And then they need to name that negative 15 is not reasonable, it's extra, which is how I've been describing extraneous.
Awesome. Great. So here's my exemplar. Is there anything from any key differences you see between mine and yours?
I see you differentiated between length and width.
That's coming from, in the regions in New York, they would mark them wrong if you didn't do it, so I think that's a habit. But in general, I think we have pretty much the same things. So that's great. Let's move on to Elijah's, because Elijah's offers some stuff that both of ours do not. And so Elijah demonstrated mastery here. So talk me through, how did Elijah demonstrate mastery, and then what does her exit ticket offer that ours don't?
What I appreciate about Elijah's is the area model that she used, which neither one of us used because we're factoring kind of mentally.
And because I've never learned how to do that. Yeah.
Yeah, well, I want them to get to that mental factoring, but this is like a good tool for every student to use, and if I say factor, they use this. Elijah also showed the work to solve this one-step equation, which I know she doesn't need to do, but she's gotten into a good habit of doing, which is good. Yeah, that's great. And she explained why negative 15 was extraneous. I think if I said that too.
You did too.
Yeah, okay.
You did too.
But yeah, I think the area model and like this part of her showing the work was all there.
Great, I would agree. Elijah's exemplar is better than ours because she provided more proof that those were the solutions to that. So let's take a look at Joseph. I wrote down the names of kiddos I wanted to look at this time. Joseph, Kavana, Darius. Arthur and Central.
I think they
Different
all
question
made
than usual. Where did they get stuck?
B.
B.
All of them.
So
All of them.
knowing that they all got stuck at B, I think this is a situation in which a conceptual error is leading to them just feeling like they can't even start the procedure. And so based upon seeing where they all got stuck, what can we assume is the conceptual misunderstanding?
They don't understand the difference between the solutions and what the length and width are. They feel like they've already answered that, I think.
Okay, so there's one conceptual misunderstanding. That's not something I captured, but that's good to write down. Say that again.
I think it's this piece. It's like this differentiating between the solution and the answer. But
and then what's the next layer of that? So these are the answers. And
right, I guess they're not clear on what those solutions mean. Is that what you're getting at? Like, the idea that, like, if x is 10 and the side length is x plus 8, then the side length must be 10 plus 8.
The conceptual error that I landed on was that students didn't think about the fact that you can have a negative measurement.
Well, so all of them wrote they can't have a negative measurement.
Right. And they all understood that procedurally.
Right, but they didn't understand that you can't substitute in negative 15. Is that what you're saying?
Right. And so I think it's the conceptual misunderstanding. I had it as just that they didn't, the context piece, but that first part of it is also correct what you said. So the first part of it, like knowing that these are answers and not the solution, and then knowing that, like, one of these is what I apply in context because you can't have a negative measurement.
Yeah.
Try to capture that in words. Let's try to name it. What is the conceptual misunderstanding?
Does this not kind of capture it? That all solutions will make this true, but only some make sense in context? Like only one of these actually can be a length? Is that... No?
No, I'm not saying how I'm processing. Because I said understanding the solution from A in context and using it to solve for X.
Well, not solve for X. They've already solved for X. To solve for the...
Using it to solve for the...
length and width.
Yeah, using it to solve for the length and width.
So we can use...
Oftentimes I put X.
So maybe it's a second part. Like, all solutions make the math true. Only some make sense in context. Use only some solutions.
Use only the solution that makes sense in context.
Use only solutions that make sense in context. One of the things, though, that we have to be careful about here is that a negative x value could work. If this was negative x plus 8, negative 15 would be the one that's true. We don't want to tell students not to use negative solutions. Like, you should substitute a negative 15, and when you see that the side length is negative, that's when you should say, nope, that can't be true. That's extraneous.
Is there ever a situation in which they are going to get a negative x?
On their test. It literally asks them the question, can you have a negative domain? Which is frustrating because it's like, yeah, technically.
So that's something to think about when we do our flex days, but I think in the terms of like teaching them to evaluate in context, and since it's a length
I want them to
problem.
like, even if they show, like, we actually went through one where we showed in the problem where we're like, let's put in negative 15. Oh, it says the length's negative 7 centimeters. Does that make sense?
Right.
Cross that off, answer C, it's extraneous.
They do understand what extraneous means, but they just got stuck on knowing what to do with this.
Yes.
So
if you can identify the extraneous one, substitute the what's non-extraneous? the one that makes sense.
Yeah. So say that again. Let's try to name it one last time. What did you capture on your paper?
I said use only solutions that make sense in context. And it won't always be lengths and widths.
So say those 2 key points again. The first one was all solutions.
All solutions make math true. Only some make sense in context. Use only solutions that make sense in context to answer questions in context. It's a lot of context.
But I think it stamps the key conceptual misunderstanding. And so as a result of addressing the conceptual misunderstanding, by default, what procedural misunderstanding are we going to address? What are they going to be able to do now?
Differentiate between the solution and the answer?
Right, they're going to be able to just plug it in. I feel as though they'll just be able to plug it in. One really great thing, Stephen, is like all kids got this first part right, which is infinitely more complex.
All kids that you have in front of you, yeah. I didn't want to give you kids that didn't... If they didn't get the first part right, they got nothing right.
Right. And so that's something like for maybe a tutoring group. But for all of these kids, and some of these kids like Joseph, I know really struggles.
Yeah, he's really been getting this.
Right.
Same with Central.
Yep. And so all kids got that first part. So this conceptual misunderstanding of like, okay, I solved, is where we got to zoom in. And then this is like Common Core math, right? This is something I never would have done probably in school. I would have just done this first part and okay, we're done. All right, so this is the misconception we're going to target, and by default we know it's going to yield the procedure. I think
so this would be the big idea that we want to stamp at the bottom, yes?
Yeah, but today we're actually going to do a model. Because we had first period was 33%, second period was 37%, and fifth period was 40%, we should go with a model. Now you don't need to model the whole thing though, because again they got the first part right. So what I'm going to do is...
Can I ask you...
Yep.
Sorry to cut you off.
No, you're good.
I didn't want to give you work that was incomplete because it felt like it's not helpful. But I think the story of that number of 33% mastery is 6-7 kids in each class did this. And the rest got all of it wrong because they couldn't finish part A.
In a time like this, what I would do for those kids who didn't do that is that's a small group reteach. Like you pull those kids at we can redo your lunch groups, especially since the quarter's ending, and for those kids who aren't doing that, that's what they need.
Even though it's a majority of the class?
I didn't realize it was the majority of the class.
Yeah. I'd say these guys are
I didn't realize it was the majority of the class. In the future, don't worry about giving, just give me high, medium, low, and don't worry about it.
Okay. And even if they're just blank?
Something like...
Or I'm getting a lot of...
There's a good example. Whenever the one was, where is that? This one, right? They got it right too. But somebody who had attempted work is helpful for me to see.
Yeah, there's a lot of people who got to this point and didn't know how to factor. They drew the area model, they even made
That's helpful for me to see. So in the future, don't be afraid to give me kids who just attempt. I actually think the attempted work is more helpful for me sometimes.
Okay.
You also can give me more, right? So you did... I appreciate that you give me 3, 3, 3, but if you want to give me 5, 5, 5, that's fine too.
Okay.
Because what I do is you've seen me, I spread them all over the desk.
Yeah.
So,
okay. But I do think that this part B is going to take our middle group to mastered.
And I think that, I hear you. I think you could model again how to do this first part if you want.
We're addressing it on Monday too in a responsive day.
And so I think that even by doing this model that I'm about to model for you, it will show the kids who don't know how to do the factoring, how to do an example, like what an exemplar would look like.
Oh, I see the color code. This is good. Great.
Okay, so I'm gonna model for you the beginning of what I would say to launch this for kids. You're gonna script the second part and then do it. Okay?
Okay.
All right. All right, so ladies and gentlemen, we're gonna take a look at this exit ticket from last week. We'll say this happens for you. So our objective on this lesson was to interpret word problems to create and solve equations with one variable using factoring and the zero product property. Now, we mastered 3 out of the 4 criteria for success. Remember that we use these as a checklist. What I'm going to do is I'm going to talk us through how we mastered each of these 3, and then I'm going to model for you how we knock off and meet that last criteria for success. So, our first criteria for success was to write an equation based on the information given. You guys did a great job at that. Look at this. This pink dot here, you can see that we wrote an equation based on the information given. We knew that the width was x minus 3, and the length was x plus 6, and that the total area is 126 units. Great job. So we checked that one off. Now we went to the second criteria for success. It said manipulate the equation to form a quadratic equivalent to 0. And so what we did there was we knew we had to get a 0 on one side, and you guys all showed really clear mastery with that, and I saw some beautiful equations that had x squared plus 5x minus 150. That met our second criteria for success. We knew we could move on to the third step. It says factor the new quadratic to solve. So we know this is a quadratic here, and I saw some of you check your work with an area model, and we got the answers of x equals 10 and x equals negative 15. And that met that criteria for success. But then some of us stopped. Oh, I saw more blank answers for B with perfect answers for A, and A is so much tougher. And so if we only go back to our criteria for success, it actually tells us what to do. Identify which solutions make sense in context and which do not. So I have solutions. Now I have to figure out what makes sense given the context of this problem. Let me do a think aloud for you for how I would solve that. And that's what you're going to script.
Okay.
What questions do you have now that I modeled?
No, I actually think that will clear up the factoring piece too for a lot of students. Just seeing it, they'll see that makes a lot of sense. I don't think I have any questions. I really appreciate the color coding too. I want to steal this paper.
You can have that pad if you want.
Can I steal that?
Oh yeah, you could. Oh no, you can have the whole thing. That way you don't have to write on it. If you want to continue to work on your script though, for what you're gonna say for how you're gonna do your think aloud. Do you need more paper?
Nope.
Let me take a minute to read that. What does it say? I'm blank going to use the solution that I'm only going to use the solution that makes sense in context. X equals 10. Great. Standing, I think that part that I couldn't read that I'm only going to use was a key thing that you mentioned before that you need to stamp, so I would underline that I'm only going to use. Because almost all the kids got A and C right, they didn't know what to use for B. I'm
Right.
only going to use. Okay.
Right. Some of them tried to plug in each one to one side and one length.
Right, I know you just sat down, but I want you to try it from start to finish. You don't have to use mine word for word, that
No,
was
but-
just to help model the model.
All right, everybody's eyes are up here in 3, in 2, thank you, Joseph, and in 1. I want to take a look at an exit we took on Monday, and I'm really excited about this exit because we actually mastered 3/4 of the criteria for success. Remember, the criteria for success is like a checklist for how to master this exit ticket. So when I look at the first criteria for success, write an equation based on the information given, I saw that almost every single person in this room was able to draw a picture and use the side lengths to write an equation of x minus 3 times x plus 8 equals the area 126. You can see this pink dot is like, yeah, we did that. We were also able to like manipulate this equation to form a quadratic equivalent to 0. So everybody in here multiplying and then subtracting 126 from both sides. So we get this nice quadratic equation, x squared plus 5x minus 150 is equal to 0. Remembering that to solve a quadratic, it must equal 0. You can see again that purple dot, yup, almost everybody in here got that part correct. Finally, almost everybody in here has mastered factoring. The new quadratic, x squared plus 5x minus 150, I saw us factor out x minus 10 and x plus 15. And we were able to solve and say, hey, x must be 10 or negative 15. And again, most people in here got that third step as well. It's really interesting to me, this is the hardest part of this exit ticket, but a lot of us stopped. I saw more right answers for A than B and C. So I want to model my thinking steps for you guys on how I'm going to answer part B. I know that these solutions will both make this equation true. They will both make it true. But
Stop.
only...
I'm going to stop you. Read the criteria for success and then say what you're going to do. Because they need to learn also better how to use the criteria for success. So go back
Right.
to that point where you just said, we factored the quadratic to solve.
So we factored the quadratic to solve, and most of us were able to get x equals 10 and x equals negative 15. So we knew how to factor this and get our solution. But this fourth criteria for success, identify which solutions make sense in context and which do not, called extraneous solutions. I know that these two solutions will make this equation true, both of them. But only some of these solutions will make sense in the context of a length and a width. When I look at this, I see x equals negative 15, and if I used negative 15 in context, negative 15 plus 8 is negative 7. Can side lengths be negative? No. So I know negative 15 is extraneous. I can actually answer part C now. Negative 15 is extraneous because it gives us a negative side length. Instead, I'm only going to use the solution that makes sense in context, x equals 10. 10 plus 8 is 18, 10 minus 3 is 7. My side lengths are 7 units and 18 units, which both make sense in the context of this problem. Checking your understanding, write your response to the question at the bottom of the paper saying, will both solutions make sense in context? Why or why not? Take 30 seconds to stamp this idea.
Great.
Go.
2 questions. First, what is the ideal response to that question?
No, because one of them will give us a negative side length, or one doesn't make sense in context.
Great. The second thing, I kind of live coached you to make sure you read the criteria for success.
Mm-hmm.
Why is it important to read the criteria for success?
I think students don't look at this generally. I think that by like naming, if you can look at this and you're stuck, this is a good way to like go through. I also think students do get 3 points done, stop, think they're done, and they're not. So if they read the criteria for success, we'd have higher mastery.
Same thing if we think back to that last week. If they would have done the GCF, we would have known. If you look back through here, just even looking to see if kiddos checked, nobody started even checking the boxes. And because it's been so long since they've done this math, you can even share with them. Miss Newald uses the criteria for success. Like I go through and check them, and that's often how I find where we're the hiccup. So how is this model going to address the student misconception?
I think it does a really good job of two things. One, a misconception of like using the criteria for success. That's going to really help in the future. It also is going to help students differentiate between the solutions and answers.
Great.
So I think it's like the key criteria for success we're diving into.
Awesome. When are you doing this? I'm making a note to myself. Tomorrow. Okay. Let me look at my calendar because I want to make sure I can come. Wednesday, and after the do now or when?
Yeah, right after the do now we need to be really quick tomorrow.
Okay. I'm going to come in then. Probably during the second period, so you can get a rep at it first. Stephen model.
Great.
Awesome. All right.